In the last section of Unit 1, you'll talk about dividing whole numbers. So again, we start with language and notation of division, dividend, divisor, and quotient. So here's a lot of different ways we talk about division that they need to be familiar with all of them. And they also sometimes, there's some confusion based on the fact that division isn't commutative. And here's some ways to think about division. How many groups of size 4 are in 12? If 12 is broken into 4 equal groups, what is the size of each group? So that's the two different types. This is called group size 4 is a repeated subtraction model, and this is a fair sharing model. And we're going to look at some examples of that, and you want to make sure students see both. Notice we also want them to start to become familiar with fractions as division. So in Unit 5, we start talking about all the different meanings of fraction, but we want them to know that one way to represent division is through this fraction form. So looking at, these two types of examples, they're important that they see each type, and I want to just draw these to your attention. I'll do this on another slide. Hopefully I can remember. So the first one, Adrian has 12 lollipops for 4 friends. Okay, so there's 12 lollipops. (10, 11, 12). And she has 4 friends. Okay, now I know this seems basic, but I really want you to just see the difference between these types. So we can think of taking 12 and you're breaking it into 4 equal groups where each group is what each friend gets. Now notice you're not breaking this into groups of size 4. At this point, we know that 12 divided by 4 is 3, but at this point with a problem like this, you could actually think of, oops, sorry, that was incorrect, dealing out the lollipops to the friends. I did it again. Ignore that one at a time. Okay, so there's those 4 lollipops. That's 1 for each friend. Then you can move on to the next 4 lollipops. So this is 1 per friend. This is now each friend has 2, and here each friend has 3. So here, if you don't actually know the answer of 3, if you modeled this according to the context, you're dealing them out one at a time, and this is called our fair sharing model. You're sharing the 12 lollipops equally amongst the 4 friends. Now let's look at the banana problem. The banana problem said you have 12 bananas and you need 4 per pie. Okay. So here, okay, I'm done with making actual shaped bananas. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Now here, notice how this is different. You take 4 to make your first pie. You take the next 4 to make your second pie. And you take the next 4 to make your third pie to get your result of 12 divided by 4 is 3. So contextually, these are really different ways of looking at division. They're both coming from the idea that 3 times 4 equals 12, but if we think of this as 3 groups of size 4, we can reverse which one the divisor is in these two types. So you want them to have the experience of both doing the last type, which was dealing them out like a deck of cards till you're out, okay, the repeated subtraction, fair sharing, or the last one was fair sharing, and then this one, the idea of subtracting off 4 with repeated subtraction multiple times until you get to 0. Okay. Going back to this, we have one type of example. This type is actually using the fair sharing model with base blocks to divide, and you could do both types. So this one says represent 564 with base blocks, and then you're going to sort them equally into these 4 bins, dividing by 4. So let's just look at that real quick. Okay, so we have 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4. Okay, and this isn't set up to do this problem, but you'll get the idea. I'll think of these as the 4 bins. So the idea, oh, it's not going to let me move them. Oh, I can't move it into that left column. Shoot. Okay, so we'll just make our bins. Oh, base block fail. Okay, let me draw a picture. Sorry, I could redo the video, but that will take me a while. Okay, so you have your 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. 564. So if you think about these 4 bins, so sharing equally among these 4 groups and then seeing how much is in each group, notice you're dealing them in like the deck of cards. You deal in these 4. Well, now you have 1 flat, okay, and you want to share that equally amongst this, so you change the 1 flat into 10 tens. Now you'd start dealing out the tens. Now I'm going to look at this. We have 10, 11, 12, 13, 14, 15, 16, and there's 4, so I'm going to give 4 of these to each bin. Again, and when you're doing this with the actual blocks, it's a little bit less messy. Okay. So now each one has 1 flat and 4 rods, and then each one would get 1 unit. Let's use a different color. Okay. And since you've used them all up, there's no remainder, and each group gets 141. Okay. Now let's look at this the other way. So if you started with this 564, you wouldn't want to subtract off 4 until you got to 0, because as you can imagine, that would take forever. So 4, 5, 1, 2, 3, 4, 5, 6. Okay, so instead of doing 564 divided by 4, let's do divided by 141. Okay, and then this is one where you may want to make the groups of size 141 instead of, we certainly don't want to line up 141 groups. Okay, so we will take, we need 500 or 141, so there's 100, there's a 40, there's a 1. So now we've made one group of 141. Notice we go to make our next group, there's not enough tens, so I'm going to cut one of these up, decompose it, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, now I'll make our next group, 100, 4 tens, and 1 1. That's our second group. Use a highlighter for the next one. 100, 1, 2, 3, 4 tens, 1 1. That's our third group. And finally we have 100. There's 1, 2, 3, 4 tens left, 1 1 left. Put those together, and that's our fourth group. Okay, so as far as modeling them, yes, we could break this into 141 groups of size 4. Okay, but that would be painful. So they can connect these two ideas, but they should see both of these different ways of modeling the division with base blocks. And I believe that's it. Let's take a quick look to make sure. Okay, so the media example only has one type. Okay, and then we also want to connect this to the standard algorithm. So let's look at that real quick. So when we did the 564 divided by 4, okay, remember we had the 4 flats, okay, and we partition them out first. So we can write this as an extended algorithm by saying that 4 went into 564. This was 400. So I'm going to write 100 here. And again, eventually you'll go to the standard algorithm that simplifies this, but they need to see where this is coming from. So I'm going to start with 100. 400, and now I'm going to subtract those off. Okay, remember we subtracted them off because we had taken the original 564 and we broke them into the 4 groups. So now they're gone, and this 164 is what we're left with. Okay, so now we had to break this into a 10. Now we had 16 tens. Okay, and then we saw that we could break those into 4. Okay, and it was really when we broke them into 4, this is gone, they were 4 rods, so that was 40. So we'll put plus 40 up here. Well, that's minus 160. We used up all the tens, and then we gave each group 1. And that was a total of 4 units, and we get to 0. So there's our 141. So I hope you see, of course, us lazy mathematicians simplified this. We don't write the hundreds and the 60s and all the place values, and we just line them up above the place value. But them seeing this idea helps them understand why we're doing this algorithm. A lot of them don't know why it works at all. They can do it, and they don't know why, and we want them to have that understanding. So use the base box in some way. It's good if you can show them both ways. The fair sharing and the partitioning, and then also show them this extended algorithm and connect it to the simplified algorithm.